Hello everyone, my name is Cristina Molinero and I'm here to present my master's thesis. This investigation has been done during spring semester 2022 and Alexander Jung has been my supervisor. The topic of my project is a multi-label classification of a hydraulic system using different machine learning methods. I have extracted my data from machine learning repository UCA, which offers a large collection of databases that are used by the machine learning community. As according to the agenda, we'll have an introduction, then a problem statement chapter, then we're going to explain our data set. Also, in addition, we're going to explain our machine learning models, then we're going to explain the results of the correlation study, and then it will be the results part of the multi-class classification and then multi-label classification. To end, we're going to have a conclusion chapter when we're going to face our project limitation and the further investigations. As our data source, and in here we present our hydraulic system. So it has different elements as the vibration sensor, the several pressure and temperature sensor according to the accumulation element, etc. So in here we can see we have two different subsystems. One is the working circuit systems and the other one is the cooling and filtration systems. As the problem statements, according to the thesis problem, there are several aspects why this thesis has been conducted. The main goal is to categorize each cycle with the health state of each of the labels. So nowadays we know that we are facing environmental issues that are affecting very much every system we're living in. Temperatures are increasing, that is related with the global warming problems, and also the world is becoming a place with less resources. And it makes us think about the future of an uncertain and alarming area. So, energy efficiency, eco-friendly systems, sustainability, erase atmospheric pollution are the solutions that all the process, either in industry, in the factory, or in any kind of industrial processes, have to be solved. And that's the reason we wanted to do this thesis, to monitorize our hydraulic system to make it more sustainable. So, and on the other hand, our research questions will be, first of all, if it's helped more to do a multi-class classification as a primarily analysis, or it would be better to just do a multi-label classification. On another hand, we'll see if the high accuracy machine learning models that we use had a follow a particular path or have theoretical similarities, and to end, according to the optimization of the data preprocessing, we're gonna discuss if it is important to have two different features data set, two dimensional differences, because we will elaborate it two dimensional data set for the features and one three-dimensional data set for the features. So according to the database, in here we present our sensors. We're going to have 6 sensors of pressure, 1 sensor of motor power sensor, vibration sensor and efficiency sensor, etc. And then also in here we present the different labels and the categories of each different labels. We can see that each category is represented about how the physical element is going, how is the health state of this physical element, and also our last label will be according to the stability. It will not be a physical element, but we will see if we can categorize each cycle each cycle as it has stability or not. Also, we're going to work with 2,205 cycles, and each cycles would be labeled as a combination of 5 label categories. So how we managed to create our data set? We had features that had different sample rates. So we had features that has, for example, 60 values per cycle, other 6,000, and other 600. So we perform an average for the features that had higher sample rate at 1 Earth to make it all of them features of 6 values per cycle. So according to the libraries, we use sklearn, an application library for machine learning methods. The standard ones, NumPy, Pandas, and for visualization, we use Seaborn and Matplotlib. According to the compatibility with the machine learning methods, as we mentioned before, we create two different dimensional datasets. One will be the two-dimensional features dataset that will have the 60 values per feature per cycle all put together as a NumPy array. On the other hand, our three-dimensional dataset will be that each feature for each cycle has a 60-element array. According to the machine learning methods, we're going to work with a multinomial logistic regression. This method constructs a linear prediction function by calculating weights that are combined in order to understand the relationship between the inputs, that will be the features, and the observations, the categories of each label. So we're going to also work with decision tree classifier and random forest classifier. According to the random forest classifier, each decision tree inside the forest is created independently from random subsets of data. And at the end, thanks to the process of majority of voting, we can predict our output. To end, we're going to work with recurrent neural networks. These neural networks are recurrent in nature, they perform the same function for every input of data, while the output of the current input depends on the past one computation. After producing the output, it is copied and sent back into the recurrent network. In particular, we're going to be using long short-term memory neural networks that are a modified version of recurrent neural networks. This one makes it easier to remember past data in memory. And this type of neural networks makes a decision whether or not taking into the consideration the current input and the output that it has learned from the previous input. In here we present our correlation analysis. We can see that the force sensor of temperatures has a correlation parameter of 1. So in the future, in a further investigation, we could use 1 sensor instead of 4 sensor of temperature. We see that we achieve a 97% in persons scale of correlation between cooler efficiency CE feature and cooler power CP feature. These two features have a disparity between them and efficiency factor SE, and also according to the pressure, we see that we have 4 pressure sensors. The first three of them are more related with each other, and the other 3 are related with each other. And we think that is the reason because, as we mentioned before, our hydraulic system has 2 subsystems, so maybe the pressure sensors that are located in one system will be more related and then with the others 3. So also in addition, labels are not so much correlated between them, and then makes us make it more relevant to produce the multi-class classification we're gonna see in the following slides. So we're going to enter this chapter of multi-class classification. Our first part will be we're going to compare the result between multinomial logistic regression and decision tree classifier. And then at the end, we're going to do a multi-class classification using recurrent neural networks. So for the first part, in here we present the 5 labels. The table at the top is according to the multinomial logistic regression, and the table at the bottom is the decision tree classifier results table. So we can see that we have very nice results in concrete with the label of wall, because it gave us very nice result as an accuracy of 1. Then according to the cooler label, the one we have at the beginning, we see that the category 100 is difficult to categorize properly, and we see we encounter this problem with the 2 methods. If we look at the pump label, we see that the better machine learning method for this particular label is the multinomial logistic regression machine learning method, because we see that it categorizes perfectly the category of 0 and 1. But in the contrary, for the decision tree classifier, we see that it has an 99.19% of categorization for the category 1 of pump. To end, according to the accumulation label, we see that is the one that has less good results. As we see if we compare the 2 methods, we see that decision tree classifier is the one that has better results. And finally, according to a stability label, we see that there is a good performance with the 2 methods, but it's clearly multinomial logistic regression is clearly the machine learning method more appropriate for this multi-class classification. In here we present our final results of the multi-class classification between multinomial and decision tree classifier. We can see that the accuracies are very high, as we see that all of them are superior to 0.292 of accuracy. And then if we look at we have performed a fold cross validation, and we see that it helps us to see that, for example, for cooler, valve, and liquid and pump labels, there is no problem of according to the overfitting, but instead with the accumulator and stability labels, we see that the main accuracy done with the segmentation of 7 data sets has been achieved a mean that is very low, and we can consider that these 2 labels have problem of overfitting. In here we present our accuracy, training accuracy, and validation accuracy of the multi-class classification analysis with recurrent neural networks. Also, according to the cooler label, to liquid label, and to stability, we see that they gave us good results when we use a recurrent neural network. But although in this case, both an accumulation label has problems of overfitting. So we can conclude that more standardized machine learning methods, as our multinomial logistic regression of decision tree classifier, are better to elaborate and to perform a multi-class classification problem. According to the multi-level classification, in this chapter, we're gonna use multi-output classification technique, and we're gonna perform it thanks to the machine learning method as decision tree, random forest, and multinomial logistic regression. After that, we're gonna do a multi-level classification using recurrent neural networks. In here we see our result using the technique of multi-output classification. In here we wanted to see if standardize our data and label binarize it also. It helps us to have better accuracy. So according to the standard and standardization, we standardize or not our features, and according to the label binarization, we binarize or not our labels. So overall, the best result is reached with random forest, as we understand this method is better than the decision tree. And also we wanted to review this multi-output classification with the multinomial logistic regression method, comparing with the random forest classifier. And then after all, we have reached an accuracy of 0.963 with random forest classifier, having a max depth of 15 and using the test size of 25%. We also reach very well results with multinomial logistic regression, but in this case, random forest gives us better performance. To end, we're going to discuss about our last analysis. It was a multi-label classification using recurrent neural networks. So in here, it was the more challenging part, as it was very difficult to have results that were relevant. In what we did as a strategy to show results that we thought will be kind of relevant was to perform this recurrent neural network algorithm with the two different datasets we mentioned at the beginning, the two different dimensional features dataset. So at our result in the left slide, in the left part of the slides, are the ones using the three-dimensional features dataset. We see that the results are not good, as our training accuracy is uniform, and also our loss is decreasing as normally, but we have some problem, and we thought about overfitting problem according to the validation. As we see, there are many peaks, and the validation is not uniform, it's not stabilized. So looking at this result, we try it to change parameters of optimizers, of activation function, etc. But we didn't find any more relevant result. So what we did was to change our input data, and our input data was now the second dimensional features dataset, and we show it into the right. We performed the same recurrent neural network, and we see in the result at the right that we reduced the instability of the validation accuracy. We also reached a higher accuracy of the training data, and also we reduced the loss, because we can see that the loss for training data in the with the dataset number 2, we reached approximately 0.43, but in the result of the right that are more relevant, we can go to a loss of 0.37. So to conclude, we have done a correlation analysis that have helped us to see that it was very relevant to do a multi-class classification, as our labels didn't have so much correlation between them. Also, we saw that for this multi-class classification, the standard models as multinomial or decision tree were the better ones, as with recurrent neural network we saw problems with overfitting. Furthermore, according to the multi-output classification, we saw it was a very good classification, because it gave us very nice results. Also, thanks to the cross-validation, we could verify our results. And then, according to the project limitation, we have seen a problem with the complexity of the time series data, and also with the compatibility between this data with the machine learning methods. We have confront overfitting challenge, and that we assume it would have been resolved faster if our level of competition would be higher than what we have. And then also working with neural network has to be more larger and more time consumed, because neural networks are very potent, are a very great tool to use, but you have to know the better parameters to make it work as you want. As a further investigations, we were thinking about using more data, so don't reduce the sampling rate as we did at the beginning. Also, we could apply classifier chain. We thought is a machine learning method that could help us to clarify more and to at the end categorize better each label in this hydraulic system. And at the end, we thought about doing data augmentation performance for recurrent neural network models, as we think we have seen very much overfitting problems that we thought with more data the algorithm will be better and will reach better results. Thank you so much.